Learning target C here is common products of polynomials, and when you look back at the first page of your notes, you'll see this table here that has all of these ones that you should be familiar with, and when you see them you should say, hey, I know a shortcut, I'll just put it back or expand it the way it's supposed to be, sort of like the difference of perfect squares or the square, a perfect square binomial. That's a good one to be feel pretty comfortable with. There's also the sum of cubes or the difference of cubes, which could be something you might want to have also. So we'll just keep that kind of over to the side while we're doing these notes and help us run through this. So factorable means factorable into integers, not into like square roots or something like that, because I can break this up. I can write it as x plus root 5 because it's a difference of perfect squares, and x minus root 5, right? But that's not cleanly factorable, so it doesn't pass the test of what it means to be factorable. Same thing here. If I have this kind of problem and it says 2x squared minus 3x minus 14, one of the things we can do is we can do 28, multiply it out, and see where that gets us. Or if I'm feeling not comfortable with all of the different products and I'm struggling to find what this is, I can always just jump over here to the quadratic formula. So x equals negative b plus or minus radical b squared minus 4ac all over 2a. And you guys like the little song, so I'll let you sing it to yourself right now. So I go ahead and plug in a, b, and c where they belong, and then I find out what this is. So grab my calculator, and negative 4 times 2 times 14 negative is 112. Okay, one of the things I see you guys do a lot is you just ignore what the value is here and you figure out a number and you always make it subtract. But remember, this is negative 4 times this, not just there for looks, right? Then we have to add in our 9 because it's actually positive. So 121. Well, how convenient is that 121 is a perfect square, and that's 11. So I'm going to have 3 plus 11 over 4 and 3 minus 11 over 4, which allows us to say our two roots must be 14 over 4, which simplifies to 7 halves, and 3 minus 11 is negative 8 over 4, which simplifies to negative 2. So this one right here is not an integer, but I think I can rearrange it to make it work for me. I know this one's easy. X equals negative 2, so I'm going to rearrange it so that it's something equals 0. So add this over to the other side, and it's going to become x plus 2 equals 0. So that must be one of our factors, because we're always looking for the two things that multiply together to give us 0 as our roots in this form. The other one is x equals 7 halves. So I'm going to rearrange this in a way that makes it equal 0, but I'm going to try to make it so that I have some number times x plus an integer answer equals 0. So I'm going to do that by multiplying that 2 out of the denominator. So I have 2x equals 7. Then finish it up so the rest of the way, and it equals 0. 2x minus 7 equals 0. So there's our other factor. So that's a different way that you can factor as a strategy. So 2x minus 7, and then our other one was x plus 2. So just a couple different strategies for you to try. This one right here, kind of weird. So I have x plus y plus 5 and x plus y minus 5. Well, if you don't think about it as like a trinomial, but instead think about it as a plus b and this is a plus b, and a minus b, you can say, well, hey, if I think about it that way, it's just a difference of perfect squares. So I know that a plus b times a minus b is going to be a squared minus b squared. So I'm going to do that here. Let this all be a, and this be b. So a squared would just be x plus y squared minus b squared minus 25. And then I'm going to simplify that up. That's just a perfect square there. Go back to black so it's easier to see. A perfect square will always be x squared plus 2ab, in this case xy, 2xy. That's one of the things that's on our common products, plus y minus 25. And that's as simplified as I'm going to get. So this is multiplying out versus factorizing. All right. This one's sort of similar here, where you can treat all of this, whoops, as a, and this is b. So if I said a plus b squared, I know that that's going to be a squared plus 2ab plus b squared. And if you need to convince yourself, you can always rewrite this as a plus b times a plus b and multiply it all the way out, but it's going to be better for you if you can memorize some of these common ones. It helps you with speed. So, all right, this is a here. So a squared is x minus y squared, okay, plus 2a x minus y b 2 plus b squared. B squared is just going to be 2 squared, which is 4. So let's simplify this the rest of the way out. I've still got a perfect square just because it's a plus b squared here and a minus b squared here. This is going to be almost exactly the same, except for this term right here, instead of being a plus, will be a minus. And again, if you need to convince yourself, you can multiply it out using the box from before. So x squared minus 2xy plus y squared plus distribute here. I'm going to multiply those together and get 4 x minus y plus 4. One more step here to go. X squared minus 2xy plus y squared plus 4x plus negative, so I'll just let that be minus 4y plus 4. Well, is there anything I can do with any of those terms to make it simpler looking? Doesn't look like it. So no more common terms to be added together. You can just go from there. Here's another one that's kind of wonky, and I wanted to make sure you recognize this trick. We looked at it before, where I have something as an exponent here that's double this exponent and then nothing on this last term. So we can use that same trick where we pretend that it's a quadratic by letting something equal like y. So we can let this whole thing represent our one term. So we can say, let's let the number e times x all raised to the third be y. And then we're going to rewrite this. So ex to the 6th is ex to the 3rd squared. So just y squared minus 4y plus 4. Okay, I'm going to factor this out. Two numbers that multiply together to give us 4, but add together to give us negative 4. Well, that must be minus 2 and minus 2. And y minus y, and then am I all done? No, because technically we weren't working with y in the first place. We were working with this instead. So everywhere I see a y, I need to replace that with the term that actually belongs there. So ex to the 3rd minus 2, quantity, times ex to the 3rd minus 2. So it's just a little trick you can use to make your life a little bit easier and knowing when to see those and knowing when to use these common products can be something that'll help you save some time.